root 3x cubed y to the fifth in rational exponent form. It's kind of like what I was just doing here. You're taking, let me get some more room in here. You're taking the, this right here, this fourth root means to the 1/4 power. Okay, so whatever it is to the 1/4 power. So each of these, the 3x cubed, y to the fifth, they're all to the 1/4 power. Okay, that's what's in parentheses. Now you're distributing this 1/4 to everything, including the 3, because there's really a 1 there. Now by distributing, you're multiplying. So it's 3, and then 1 times 1/4 is 1/4. X, 3 times 1/4 is 3/4. Y, 1/4 times 5 is 5/4. You're just multiplying those exponents.
Okay. 1. Okay.
Does that make sense? Maybe.
I guess you just put the 4 underneath each number.
Yes, essentially.
Looks like it.
When you multiply by a fraction with the 1 on the top, you are doing just that. Yeah.
Okay.
All right. What do we got next here? Number 3 here. But just make sure if you have a question about which one it is, let me know. Hopefully you can figure that out.
Okay. Oh, I'm fine. We can go to 3.
Great. All right. So which of the following is the name of the longest side in a right triangle? So here's a right triangle here. There are legs. Legs come out from the 90. The conjugate's completely unrelated. Obtuse has to do with angles, which is not part of the triangle here. And so the hypotenuse is always the longest side. Hypotenuse is always the longest side. That's just a pure definition there that you'll need to remember, especially for geometry, which I assume is next year.
Sadly.
All right. Yeah. Okay. Which of the following is a like radical with 4 square root 6? Okay. Well, I think what they're saying is, and we talked about this last time, it's something that you can add. So I'll just write all of them. All right. You're looking for what are called like terms here. Now that I've written it out, does anything stand out to you as a like term?
C and D.
Okay, so I agree. Kind of they look the same. Now the index has to be the same. What is the index here in C?
3.
And the index here that's not written, what is that if it's not written? 2. So these two are like terms, like radicals.
Okay.
All right, number 5 here. Number 5. So here we go. Pythagorean theorem, really important. One of the most important things you'll see in math. The legs are always A and B, leg, hypotenuse. And it is always A squared plus B squared equals C squared. Nothing less, nothing more. Which one would that be?
A.
It is A. Really important to know that. You'll see that over and over again. I'll ask you that, and hopefully you'll give me the right answer. All right, which of the following is the principal root of the cube root of -8? The cube root of -8. So you want to go to a calculator if you have it. Do you have a calculator available to you?
The only one that I would have would be the one you would send me.
Okay, let me drop it in the chat here. Sometimes there are problems where you can just go right to the calculator and this is one of them. So if you can give that a try, I'll definitely jump in and give you some help if needed. Let's see if you can make some sense of that.
Okay, that would be C -2.
You are correct. Very good. All right, we're making good progress here. Let's see here. Then I lost my page. Okay. Conjugate. All right, so we got to talk a little bit about what a conjugate means. Conjugate. I'm not sure we talked about this last time. Maybe we did. All right, so a conjugate is something like this. Let's say it's 1 plus the square root of 2. The conjugate would be 1 minus the square root of 2. What is different about this top one and this bottom one?
One is positive, one's negative.
Think of it as add and subtract here for a moment. Now let's say it's like -3 minus 5 square root of 2. Here's the conjugate, -3 plus 5 square root of 2. What is the difference?
You're subtracting, or you'd be adding.
So it switches operator. If it's positive or plus, it becomes negative, or subtract. If it's subtracting, it becomes plus right here, like that. Now, that is the only difference. So when you look at 4 minus square root of x, you're looking for the one that's exactly the same, except for that subtraction symbol. Which one would that be?
B.
It is B. Good. All right. Very good. All right. So we're up to 8 now. It says to simplify each expression. All right. So number 8 here is 7 squared minus 3 cubed. Now, I believe you have to show a little bit of work. Is that right?
Yes.
Okay. So could you tell me the value of 7 squared?
Let's say 14.
Try again. Squaring means
Valid.
you're multiply
Mhm.
them together. 7 times 7.
Okay. That'd be 49.
Okay. And 3 cubed is 3 times 3 times 3. What does that become?
That would be 9.
Okay.
49. And then subtract by 9, which would be 40.
Good.
Okay. Let me grab this.
Let me know when you're back and we'll keep going.
Let's see if this works. Hold up, I need to grab something real quick.
Sure.
Okay. I have.
You ready?
Okay. Square root m fifth power. Okay.
Question?
No, I'm just was reading it.
Okay. So yeah, so we've done a bunch of these last couple lessons. It's the square root of 12 and the square root of m to the 5th. Do you remember how to break apart either of these?
I do remember, I think for the m fifth, you would bring it down and have m to the 4th power and then just m.
Okay, I like it.
And I believe multiply. I'm gonna say, yeah, just multiply it.
What was when we wrote this earlier? The square root is what exponent?
2.
Try again.
Oh,
Square root
and
of
that
it.
was index.
Yes, the index is 2. It's 1/2.
1/2.
And do you remember how we multiplied each of the exponents by 1/2 in an earlier problem?
Mm-hmm.
So you're going to do that here. What is 1/2 of 4?
4.
Yes, the exponent. Yes.
That would be m 1/4.
You're multiplying 4 by 1/2.
Hmm.
4 times 1/2.
Oh, 8.
Try
Oh,
again.
no, it would be.
Nope. Try again. You're welcome to use that calculator. I'm not anti-calculator. I want you to get the right answer.
4 times, let's see, 1/2. 1. Where's do you know how I can make it a Oh, here it is. I found it.
Yep, fraction bar.
1, 2.
2.
Oh,
Okay, so it's m
oh,
squared.
so it's
M squared.
that's dividing. Okay.
Okay, so multiplying by 1/2 is the same as dividing by 2.
Okay.
All right, now this 12, you got to break apart with a prime factorization. What is the smallest prime number that we should start with?
1 and 6.
2
No,
and 6.
2 and 6.
And then if it works, you try it again. Does 2 go into 6?
Yes,
2
2 and 3.
Okay, so you bring the 2 out, 2 square root 3. So your answer consists of the part inside the root and outside the root. What stays outside the root? What stays inside the root?
2m squared.
Okay, I like it. Square root of
3m.
3m. Very good. There's your answer. All right, so let's grab the next one here. All right, so this is the cube root of minus 27z to the 4th. So we're going to break this into 2 problems here. The cube root of minus 27 and the cube root of z to the power of 4. Okay, why don't you see if this part can be done in the calculator, please?
Square 3. -3. And then the next one, okay.
So this one here, you've got to look at it as like we were doing before. You break this apart into the cube root of z cubed times the cube root of z. Basically,
Okay.
that 4 breaks down to a 3 and a 1. So in this case, the 3 and the 3 cancel each other because it's really z cubed to the 1/3 power. And 3 times 1/3, what does that equal, Josh?
3 times 1/3. Let's see. 3 times 1. 1.
Is 1. So this is just z to the 1 here. The -3 comes down, and then you've got the cube root of z. So you have parts outside the root and inside the root.
Okay. So the outside would be -3z. And then
Cube root of z.
with z.
Yes, you got it.
Z. Z. Okay.
All right, so it's a little slow down in our our trajectory here, but we're going to get back to doing a little bit faster questions here. Let me know when you're ready and we'll look at number 11.
Okay.
All right, so number 11 here. It says determine the length of the missing side of each right triangle. So you want to draw your favorite right triangle. You want to probably draw it the same way every time. If you don't like the one on the left, we can also use the one on the right. Do you have a preference here for which one you like?
Or so the left one.
Okay.
The other one, the left one.
Okay. So now the labeling here is important. A and B are the legs. C is the hypotenuse. Okay. Are they giving you the value of A, B, or C in this problem?
A is 15, so I'll write that down. A 15, and C is 20.
C is 20. Okay. And we know that A squared plus B squared equals C squared. 15 squared plus B squared equals 20 squared. So you're substituting the numbers that they're giving you into this formula.
3 plus blank equals 40. Okay.
Okay, so now I want you to figure out 15 squared. And remember, it's 15 times 15. 20 squared is 20 times 20. You're not multiplying by 2, you're squaring. Squaring means multiplying by itself.
Okay. This would be blank. And then yeah, this would be okay. So what I have is 225 plus blank equals 1600.
20 squared is not 1600. It's
Oh, 1600.
no, 20 squared is 400. 20 to the
So then
power
what
2.
did I
20
do?
times 20.
40.
40 squared is 1600.
Oh. Okay, there we go.
Okay, now you're gonna subtract 225 from both sides of the equation, and it's not a blank. Treat it as b squared. Is that okay?
Yeah, I'm writing this
All right.
on this piece of paper here. So then that 400. It's 175. So we get 0 here. 175.
Okay, so now you go to your calculator and you hope that this works out nicely, but if it doesn't, we have to reduce it the way we've reduced other roots. Okay, so I'm pretty sure when you go to your calculator, you're going to find that this does not work out nicely. So we will need to reduce the root.
Okay. B. Okay.
All right, so to do this, we're going to start with 3. Okay, and we're going to find that 3 does not go into 175. So then you move to 5. Is 175 divisible by 5?
Yes.
Okay, what's the next number?
I would say
Just go to your calculator.
35.
35, perfect. And then you try 5 again. Does 5 go into 35?
Yes. 5 and 7.
Good.
7 does not go into 5.
Yep, so we're done. 7's a prime number. So this becomes 5 square root 7. That's your value of b.
Okay.
Any questions on that?
No.
All right, so we're on to number 12. It's another right triangle here. So again, good to draw the same right triangle every time. That way it's consistent. A, B, and C. This time they're giving you A is 9 and B is 12. Okay, so make sure you draw that triangle and then write the Pythagorean theorem. A squared plus B squared equals C squared.
Okay. So then we have A equals 9, B equals 12, C equals blank. Okay.
So you're gonna put these values into the Pythagorean theorem. 9 is A, 9 squared, B is 12, 12 squared equals C squared.
Okay.
And I keep hearing you say the word blank. I'm just curious, are you actually writing the variable or are you actually just leaving it empty?
I just write a little blank for C equals, then just like with the question mark, how is in my book, just a line, nothing's there. So
I see. Okay, got it. All right, so you're going to go to your calculator. You're going to square 9. You're going to square 12.
9, 81. 81 plus 141. I mean, 144.
Good.
And then equals C squared.
Yeah, so add them together now. Add those two numbers.
Oop. 225.
225 equals C squared.
Okay. down.
Okay, so take the square root of 225 and maybe it's a nice number.
Times 225. Oops, too big. Am I supposed to times 225 by 225?
No, you're taking the square root. You're undoing
Oh, okay.
the c squared. C squared is undone with the square root.
Divided by 5 would be 45.
No, Josh, just go to your calculator and sometimes you just try it. Maybe you get lucky and it works.
Mm-hmm.
Square root of 225.
Okay. 15.
15. So C is 15.
C equals 15.
If it didn't work, that's when you would use the reducing.
Okay.
All right. 13. Square root of 3 over 2. Okay, so the first property to remind you of is whenever you have a fraction inside a square root, you take the square root of the top and the square root of the bottom. So this problem is the square root of 3 over the square root of 2. Okay,
Mhm.
but we're not done, but that's the first part. Now, every problem says to rationalize the denominator. Rationalize the denominator. So that's referring to this right here. You can't leave it like that. Do you remember what we multiplied the top and bottom by to rationalize the denominator?
By the same number? No.
Yes, square root of
It
2,
is.
square root of 2. Yes. And that's why I'm asking, because eventually you're going to know all these answers and you're going to not need me. You're going to just know what to do. On the bottom there, the square root of 2 times the square root of 2, what does that become?
That would be 3 times 3, 6.
No, on the bottom. We'll get to the top.
4.
Square root of 4. The top is the square root of 6.
Mhm.
What is the square root of 4?
That would be square root of 4.
Yes. What does that
2.
reduce to? 2. And then the square root of 6 remains the same. So there's your final answer.
Interesting. Just write this down. Okay.
You got it?
Mhm. I wrote everything down. Okay.
Okay. Next question here. It's 5x over the square root of 5. So for now, just ignore the fact that there's a 5x. Think of it like we did in the last problem here. What did you do to rationalize the denominator?
We multiplied it by 2.
Square root of 2.
Mhm.
It's the same thing here. You're going to multiply the top and bottom by the square root of 5. Right. So what does the bottom become? Let's just focus on the bottom.
That would become 25.
The square root of 25. Now in the numerator, there's no square root. So there's nothing to combine. You just have to separate them where there's stuff on the outside and stuff on the inside.
Mhm.
Okay. What does the square root of 25 become on the bottom?
Came I'm saying 5.
It is 5.
5
Now sometimes you can still reduce.
reduce 5x and 5.
Yeah, so the 5s would cancel and it just becomes x square root of 5.
Mhm. Okay.
All right. So let's keep going here. We're on to 15. This one is much more difficult, but you'll be able to do it, no problem. All right, so the difference between this problem and the previous one is there's more stuff on the bottom than just the square root. There's also this -4. Do you remember the conjugate stuff from earlier? Do you remember what we did with conjugates?
I'm looking here.
I think it was
We
question
were,
like,
it was, yeah, I remember. It was just basically the opposite. If it was a negative sign or subtraction, it would be a addition.
yes. So in this problem, you're going to take the square root of x and add 4, square root of x and add 4, but you have to multiply both the top and the bottom by this. All right, so on the bottom, we're going to use FOIL. Do you remember that from earlier in this course, FOIL?
So we're gonna have to do the bottom one FOIL?
Yes, we're going to
Okay.
FOIL the bottom one. So think of it as f times the first square root of x times the square root of x. Can you tell me what that becomes?
That would become square root of x squared.
Okay, but that reduces, right? The square root and the square, they undo each other.
What? I didn't hear.
Doesn't the square and the square root undo each other?
I guess so.
Okay. Let me think about whether we should, yeah, we probably should talk about that. Remember, the square root of x is x to the 1/2. So if you have an x squared, it's x to the 2/2. 2/2 becomes 1. So just x to the 1.
Okay.
All right, now we have to do the outer. Square root of x times +4. What does that become?
Ooh, that would be 4 square root of x.
Okay. And then the inner is -4 times square root of x. What does that become?
We're doing inner -4 and x. That would be, yeah, -4x.
Square root of x. Yep. And then the
And then,
last, -4 times +4 is?
-8.
You're multiplying.
Multiplying. Oh yeah. 16, -16.
-16, good. Okay. Now, do you notice anything that might be a like term in the bottom there?
The 4 square root of x and then -4 square root of x.
Okay, those are going to cancel.
Oop. Okay, so then we have x and -16
on the bottom. Now on the top, that 3 is going to multiply the square root of x, and that 3 is going to multiply the 4. What does that become?
3x and 12.
3 square root of x plus 12. I think that's about the 5th time you said just the thing under the root. You have to say this symbol. This symbol means square root. You have to say it to be clear.
Okay, I have it written down.
All right, fantastic. So we're ready to move on to 16.
Let me just actually write this here. Okay.
All right, here we go. Get this in. All right. So what do you see on the bottom this time?
Square root of 3 minus square root of 2.
What would the conjugate of that be?
Square root of 3 plus square root of 2.
Very good. We're going to multiply the top and bottom by that.
Okay.
All right. Now on the bottom, we're going to FOIL again.
First would be 3 and 3. Would be 9.
Square root of 9.
Square root of 9. And then the, what was it?
The O.
So that would be outer. That would be square root of 4.
It's the square root of 6. 3 times 2 positive square root of
Oh.
6.
Wait, we were doing outer. Wouldn't that be square root of 2 and square root of 2?
Square root of outside. The outside means the left and the right one.
Okay, so square root of 2 and square root of 3. Okay.
Yes.
Negative square root of 2.
No. That square root of 3, and then this square root of 2. That's the outer. They're like the one that's on the left and the one that's all the way on the right.
Okay. That would be square root of 6. Multiply.
Okay. Now you're going to do the inner. Minus square root of 2, positive square root of 3.
That would be square root of 6, negative 6.
Negative square root of 6. And then your last one is minus square root of 2, positive square root of 2.
That would be square root of 4, negative 4. Yeah, square root of negative 4.
It's the negative square root of 4. The negative comes on the outside.
Oh, okay. Oop. Okay.
Now, do you see any cancellations?
Square root of 6 and negative square root of 6.
Okay. And then what about the square root of 9? What does that become?
Square root of 3.
3, just 3. What about the square root of 4?
Negative 2.
3 minus 2. Okay. What is 3 minus 2 in this case?
1.
It's just 1. Good. So the bottom just goes to 1. Okay.
Mhm.
Everything we just did was all for the bottom. Now in the top, there's not much to do. There's this 1, square root of 3 plus square root of 2. But if you multiply by 1, does it change anything?
No.
So those just keep coming along for the ride. Okay, so this is your final answer, but you really should just write it as the square root of 3 plus the square root of 2. You don't have to write the division by 1.
So 3 plus root of 2. Okay.
Right. Let's take a look at number 17. Here's 17. We're going to find the distance between these 2 points. So there's this thing called the distance formula, square root x2 minus x1 squared plus y2 minus y1 squared, square rooted. Have you seen that before?
I think so. Yeah, I remember something like this.
We have not done anything on this yet, but
I remember something in class. Yeah.
okay.
About that.
So the point 1 is like x1 and y1, and point 2 is x2, y2.
Oh yeah, I remember a little. Yeah, something.
So this means that we are going to subtract. We're going to put these numbers in and then subtract. So x2 is 3. What is x1 in this case?
2.
2. Plus, what is y2?
That'd be negative 1.
Minus 7 squared.
Squared. Okay.
All right. So now you've got to do the part inside. What is 3 minus 2?
1.
1 squared plus, how about negative 1 minus 7?
6
They're both
squared?
they're both negative, so that means the answer is negative for sure. Notice they combine together.
Would be -8
-8, yeah.
squared.
Right, so that is 1 plus 64 or the square root of 65.
Okay.
What do you think of that? Is that okay?
I'm a bit confused where we got 65 from.
What is
Oh,
what is 1
because
squared?
that would be 1.
Okay, so we have 1 plus -8 squared is 64. Add those together, and
Oh, okay.
it becomes 65.
Okay.
All right, fantastic. So let's move to number 18. It's really similar.
So
All right. Point -5, comma 1, point 2, comma 0. You label your first point x1, y1, and then x2, y2. Then it goes in the formula here, x2 minus x1 squared plus y2 minus y1 squared, like that.
and then so 2 minus or just -5.
Well, no, the x1 is -5, and that subtraction still comes down. So you either write them both, or you have to combine them right away. Do you know what I mean by that? Two negatives, they make what?
A positive.
Positive, yeah. So you could go right away and just say, okay, it's 2 plus 5,
Okay.
or you can wait to do that.
We can do it now. I guess make it easier.
Okay, so that's 7 squared, and 7 squared is 49.
49. Okay. And then what about the y?
Okay, so same thing here. What's y2?
Y2 would be 0,
What's y1?
1.
Okay, what is 0 minus 1?
1.
Nope.
No, that's 0. Yeah.
Nope, nope. 0 minus 1. You have nothing, or you don't owe anyone anything, but then you owe them $1. How much do you owe them?
So you owe them nothing.
Then you borrow $1.
So you owe them $1.
And we think of owing as being negative.
Okay. So just say 1.
Okay, so that becomes just 1. 7 squared is 49. And you're supposed to take the square root in every step here. So we'll combine these numbers, square root of 50. But maybe we can reduce that.
Oh. Reduce 50.
So we do that by breaking it apart with a prime factorization. So 2, what number times 2 gets you to 50?
2 and 25.
Okay. And then 2 doesn't go into 25, 3 doesn't go into 25, but 5 does, 5 and 5. So that allows you to bring it.
You were saying
5 comes out and 2 stays in.
Okay. 5 comes out. 2 stays in and the square root. Okay. There.
So it becomes 5 square root 2.
5 square root 2. Oh, okay.
And that is your distance. So your distance is the 5 times the square root of 2.
Oh, wow.
All right,
Okay.
so you got some problems left here. What's your plan to finish this?
I could see if I could do it myself, maybe. Just try to maybe
Yeah.
learn it a little on my own. Just look
Sure.
at my book and
Sure. I've got some times tomorrow. If